Let's spend some time reviewing the trigonometry that we're going to need to know in order to be successful in calculus. Now, the word trigonometry just means literally three-angle measure. So the three-angle part, of course, refers to triangles. Those are the shapes that have three angles, and that's going to be closely related. But what we want to discuss is what's an angle, how do you measure it, and what are these things, sine and cosine, that we keep talking about. So if you have an angle, basically you just have two rays, half-infinite lines, that share a common endpoint. It's called a vertex, right? And that creates what's called an angle. So you think about an angle as something that a geometric shape could have at one of its vertices. A lot of times, though, we think about angles as indicating some kind of turn. If you're going to turn, you need to have a start and an end. So the starting ray we call the initial ray, right? So that means the starting ray, and the terminal ray, to terminate means to end. Terminate means to end, so this is our terminal ray. So if this is our initial ray and that's our terminal ray, then that indicates not just an angle, but a directed angle, because we're turning in a particular direction. On the other hand, if our initial ray was here and our terminal ray was up there, then that would be how we'd indicate that by an arrow this way, right? We're turning an angle in this direction. So when we specify an initial ray and a terminal ray, then we get what's called a directed angle. Now, to measure an angle, usually what we do is we put the initial ray along the positive x-axis. So if we do that, we're putting the angle into what's called standard position. So with our initial ray this way, with our vertex there at the origin. So to measure an angle, one method is to use 360 degrees. So you just break the circle up into 360 equal parts. Now, 360 might seem like a weird number. It's very close to the number of days, though. So the circle of a year is 365 and a quarter days. So 360 is kind of close to that, at least 5 days, so you can kind of party between Christmas and New Year's. But it also has some nice properties. Let's see, its prime factorization is 5 times 8 times 9, so it's divisible by 5, 8, and 9. In particular, it's divisible by 2 and 3 and 5, so the first few primes. That makes this number divisible by a lot of different things, which if you're talking about slicing up a circle into a bunch of angles, that's handy. It's not maybe the most natural way, but it is the most common way, so probably the way you learn first. So 360 degrees would be to go all the way around, right? That would be where the initial and terminal ray here are separated by one whole circle. If you cut that in half, though, then this angle would be 180 degrees, of course, right? And if you only go 3/4 of the way, then that would be 270 degrees. Here's an important one, right? 90 degrees if you just do a quarter turn. And let's see, we can divide that 90 degrees into two parts. That would make this a 45-degree angle here. Or divide that up. Let's see, we could divide it up into 3 equal parts. So we could make 3 equal parts. This would be then 60 degrees and 30 degrees. These are important angles, particularly because they're a case where we can calculate sort of the horizontal and the vertical, so I should have said horizontal this way and vertical distance that way when we have a particular circle. So 35 multiples of 30 and multiples of 45 end up being very important angles just because they're pretty common and easy for us to deal with in some special cases. So it's not necessarily, 360 is not necessarily the most natural way to measure an angle, and in calculus we'll focus on another way that is much more natural called radian measure. Now here's the idea of radian measure. The radian measure, if you want to measure an angle, what you're going to do is you're going to put your angle in standard position. So you put your initial ray here, and then your terminal ray will go out and cut through this circle here. This circle, whatever its radius is, that would be this distance, right? From the center of the circle to where your initial and terminal ray cut the circle, that distance would have to be the radius. What we're going to do is we're going to measure the arc length. So that would be the distance along that circle. And we're going to divide that arc length by the radius, and that's how we're going to get the radian measure. So this is the definition of radian measure. It's arc length divided by radius. Now we have one length, right? The arc length, the distance along the circle, divided by another length, the radius. And so this has no units, right? It's actually unit-free, or even has no dimensions. Length divided by a length is going to be a dimensionless quantity. So that makes radians pretty nice. Here's another useful thing about radian measure, so a property that degree measure doesn't have. If you know the radian measure and you know the radius, then you can calculate the arc length pretty quickly. You just multiply the radian measure times the radius. So if you have the degree measure and multiply by the radius, you get something that's more meaningless. But this is kind of a handy thing, right? You can see if you make a small change in the angle, but you follow that change for a long distance, you're going to be off by a large arc length. So that's the problem. That's the idea of having a small variation in course, right? The further you stay off course, if you don't go very far, then you're not off by very much. But as you pursue that course for longer distances, then the arc length here gets larger and larger and larger in proportion to the radius there. So in particular, if your circle happens to have radius 1, and when we have a circle of radius 1 centered at the origin, we call it the unit circle. So if the radius is equal to 1, like on the unit circle, which is the circle we'll commonly use, then the radian measure is actually the same as the arc length. So that gives a nice physical interpretation for the radian measure. So let's look at some common angles again. So if you go all the way around a complete turn, we know that the circumference of a circle is equal to pi times the diameter. Of course, the diameter is 2 times the radius, so the circumference is 2 pi r. If the radius is 1, then to go all the way around is 2 pi times 1, so a complete turn would be 2 pi. If you only go half a turn, that's only pi. If you go a quarter turn, pi halves, that's what we normally call 90 degrees, right? Down here, this was 270 degrees, but that's going to be pi plus another half pi would make 3 pi halves. And then here, this would be an eighth, right? So 1/8 of 2 pi would be pi quarters. See, that would make this one 3 pi quarters. Hopefully you can figure all these out on your own, probably even more efficiently than I can. 7 pi quarters over here, right? And the beauty is, if we're thinking that the radius is 1, so that this distance is from the center out to the rim is 1 on the circle, it's a unit circle, then that angle measurement is actually this distance. So to go, the meaning of an angle of pi force is that on a unit circle you would travel a distance pi force as you turned along that circle. So the arc length would actually be equal to the angle in that special case where it's a unit circle. Of course, it's the radian measure is actually the arc length divided by the radius, or the arc length is the radian measure times the radius, as we discussed before, but on the unit circle that's kind of a special interpretation. That's much more natural to measure the angle in terms of an actual distance traveled, or a ratio of distances anyway. So this will be our preferred measure of angle measurement. Hopefully you'll get good at it. Let's see, before we looked at 30 degrees. That's going to be just a 1/12 of a circle, that's pi sixth, and 60 degrees is a 1/6 of a circle, that's pi thirds. Now you can always convert pretty easily between the two, because you know that pi radians is equal to 180 degrees. So this fraction pi divided by 180, that's actually equivalent to 1, right? They're the same thing. 180 degrees is the same thing as pi, so any number divided by itself, that's, well, we should say maybe equivalent to 1, right? So if I multiply some number by pi divided by 180, I'm multiplying by something equivalent to 1, all it can do is change the units. For example, let's see, if you have a 60-degree angle and you multiply it by pi over 180, then let's see, the zeros cancel here, right? And 6 goes into 18 3 times, so we get pi thirds. Of course, the units of degrees are in the top and the bottom, so they cancel. So you get this dimensionless quantity, pi thirds radians. 60 degrees multiplied by something equivalent to 1 converts it to some other equivalent measure in a different measurement system. So, or if we have the angle pi fourths, and we multiply by 180 degrees over pi, then the pi's cancel, and 180 divided by 2 would be 90, divided by 2 again, and you get 45, so this is 45 degrees. Pi force, it's the same thing as pi force times 180 degrees over pi, since these two things are the same. So that converts back to degree measure. So you could always use these two conversion factors to move back and forth, particularly if you were rusty, but we'll use this so much that you'll just remember that 2 pi is all the way around, pi is halfway around, pi halves. You can figure these out. Pretty simple. Alright, so make sure you've practiced that though, so that when you see these angles you recognize them. In particular, if we're talking about degrees, the important ones are the multiples of 30 degrees and the multiples of 45. If we're talking about radian measure, which we'll most commonly do, the important ones are multiples of pi sixths and multiples of pi fourths.